Okay, let's go over the nomenclature a little bit for this hovercraft. So I've got a little model here of a hovercraft, and this white foam I've got underneath it, I'm going to use that to represent the air because we can't see air. So let's imagine this white foam represents the air. And so if I looked at the footprint of the hovercraft, I said, what's the deck area of the hovercraft? Well, that matches the deck area of this air, so I can go ahead and use this. So if I look at the deck area, that's the square inches or square feet of this whole surface. That's the deck area. The perimeter of the hovercraft, of course, is the perimeter around the edge of this air cushion. Again, white foam represents the air. So deck area, perimeter of the deck. Of course, the thickness of this white foam represents the gap height. And it's about 1.5 inches, which is, of course, vastly exaggerated. You want about 2 millimeters. So, but you wouldn't be able to see 2 millimeters. So I'm exaggerating it here at 1.5 inches. So that's the thickness of the air cushion. Now the gap area is the last thing we have to talk about. That is the surface area of this edge. So there's the perimeter times the thickness gives us this area, which is represented by all this stuff as you go all the way around the whole edge of this thing. And that's the area where all the air is shooting out in every single direction at that leakage velocity. So imagine again, this white foam represents the air. The air is shooting out in every direction. It's shooting out where? Well, it's shooting out through this gap area, which is the edge of this foam. Of course, the top sits on top of the hovercraft. The bottom is the floor. So it has nowhere else to go but shoot out all the sides, since that's the gap area. Gap area, perimeter, deck area.